Everyone has heard of Schrödinger's cat, a cat in a box, somehow alive and dead at the same time. Until someone opens the box and looks. It's the most famous idea in all of quantum physics, and for 90 years it came with a comforting catch. It was just a thought experiment, a metaphor, because everyone knew the real rule that quantum weirdness, being in two places at once, only happens to the tiniest things. Single atoms, lone electrons, never anything you could actually see, never anything solid. In early 2026, a team in Vienna broke that rule. They put a solid object in two places at the same time, the largest object ever shown to obey the strangest law in physics. Schrödinger's cat just stopped being a metaphor and started being an experiment. The experiment came out of the University of Vienna, working with the University of Duisburg-Essen, published in Nature in 2026, led by a doctoral student named Sebastian Pedalano. They took clusters of sodium atoms, about 7,000 atoms each, roughly 8 nanometers wide. They fired a laser to fix each cluster's position to an accuracy of about 10 nanometers. And that same laser placed each one into a superposition, meaning it could follow more than one path through the apparatus at the same time. When those possible paths overlapped later, they produced a striped interference pattern. And that striped pattern is the fingerprint. It is the unmistakable signature that the object did not take one path. It spread across a region dozens of times larger than the particle itself, the total mass, more than 170,000 atomic mass units, heavier than many proteins, in the range of a small virus. Let me say that again because I want it to land. A speck of solid metal, as massive as a small virus, was demonstrably in more than one place at once. Not light, not a single atom, real solid metal, the kind you could hold in your hand. Here's the comparison that shows how far we've come. In 2019, the record for this kind of experiment was a molecule of about 2,000 atoms, weighing around 25,000 atomic mass units. This Vienna result is roughly an order of magnitude beyond that by the measure physicists actually use, called macroscopicity. In physics, that is not a step. That is a leap across a chasm everyone assumed couldn't be crossed. And here's the part the lead author said out loud, which I love for its honesty. Intuitively, you'd expect a lump of metal that big to behave like a normal classical object sitting in one place, like everything you've ever touched. It didn't. It behaved by the rules of the quantum world. Here's the three-part pattern I want you to see because it's bigger than any one experiment. First, there is no proven size limit on quantum mechanics. We always assumed the quantum rules switch off once things get big enough to see. This experiment says we have no evidence of a hard line. We just keep pushing the boundary outward and quantum behavior keeps holding. As Pedalino put it, quantum mechanics itself doesn't state any limits, and that's exactly what they're testing. Second, the reason we don't see this in daily life has a name: decoherence. When an object touches its environment, air, light, heat, other particles, the superposition collapses into a single definite reality almost instantly. That's why your coffee cup is in one place. Not because big things can't be quantum, because big things can't stay isolated. The everyday solidity of the world may be less a law and more a side effect of everything constantly bumping into everything else. Third, and this is where every person who has ever wondered about meaning should sit up straight. This experiment drags the deepest question in physics back into the open. What makes reality settle into one definite thing? When does the haze of possibility become the outcome? Some physicists say it's the act of measurement, some say it's observation, and some, looking at this very result, wonder whether the possibilities don't collapse at all, but branch into a multiverse of every outcome at once. Now, here's where I have to be careful. More careful than usual, because I want to be honest about what we know and what we don't. The experiment is solid. The superposition is real, peer-reviewed, published in Nature. That part is not in question, but what it means, that's where physicists genuinely disagree, and I won't pretend there's a consensus where there isn't. Whether reality needs an observer, whether consciousness plays any role at all, whether there's a multiverse, these are competing interpretations, not settled facts. Anyone who tells you this experiment proves the universe needs a conscious mind to exist is reaching past the evidence. So let me hold this honestly. The data is rock solid. The meaning is a wide open, beautiful, unfinished question. And here's what I think is true anyway. So let me bring this down to what it touches. For technology, this is the kind of work that feeds into more sensitive quantum sensors and tests the outer limits of quantum theory itself. The team is already working on putting biological matter through the same setup, which would push quantum interference into a whole new regime. For physics, this is a direct experimental probe of the border between the quantum and the classical, the question Schrödinger himself was pointing at with that cat. We are finally testing it instead of just arguing about it. For philosophy, the comfortable wall between the strange quantum basement and our solid, dependable world is cracking. Those were supposed to be two different realities. They may be one reality, separated only by scale and isolation. And for faith and meaning, here is the quiet wonder. The solidity you trust, the floor under your feet, the certainty that a thing is in one place may be a gift of relationship rather than a brute fact. A thing becomes definite when it stops being alone, when it touches the world around it. There's something almost scriptural in that shape. That definite reality emerges through connection. I'm not going to claim physics proves a theology. I'm telling you the shape of the finding is hauntingly familiar to anyone who's read the old wisdom about a universe held together moment to moment by something outside itself. I've always believed the strangeness at the bottom of reality is the point. A universe this odd, this layered, this resistant to our intuitions looks less like a machine that built itself and more like a work with an author. This experiment doesn't prove that, but it humbles the people who were so sure the universe was simple and self-explanatory. And humility in front of something this strange is the beginning of wisdom. Here's my honest forecast. By 2030, I expect these superposition records to keep falling. Bigger objects, heavier masses, the boundary pushed further into the visible world. By 2035, I expect this work to feed directly into quantum sensors and quantum computers far beyond what we have now. By 2040, I think the question Schrödinger asked, where exactly does the quantum world end and ours begin, may not have a clean answer, because the honest answer might be it doesn't end. It's all one thing all the way up. So where do you land in this? If you're a scientist, this is one of the most thrilling experimental frontiers alive, the literal testing of where reality decides to be real. If you're a creator or a thinker, carry this model. Certainty and solidity are not the default state of the universe. They're what emerges when things connect. Sit with how much that reframes. If you're someone of faith, take heart and stay honest. The most important questions about reality, observation, and what holds the world together are coming back into open conversation on the physicist's own terms. Hold the wonder. Don't overclaim the proof. And if you're just a person trying to make sense of this strange moment in history, here's the thing to hold. The world feels solid and certain. At the deepest level we can measure, it is neither of those things by default. It is a haze of possibility that becomes definite through connection. That should make you feel less like a cog in a cold machine and more like a participant in something still being written. Every massive shift in history has had a window, a stretch, where the people paying attention had a structural advantage over the people who weren't. The frontier thinkers who can hold science and meaning in the same hand without flinching at either are going to be the first movers of what comes next. This is exactly why Julia and her team built First Movers, to help you actually live and work at the leading edge instead of watching the future happen to other people. If you want to build a real future at this frontier yourself, AI Labs is the school. 500 plus students, live instructors every week, new training added weekly for a fraction of what this level of teaching should cost. Link in the description. And if you're a founder with revenue and a willingness to move, and you want your AI media empire built with you in the room, that's the Clone Mastermind taught in person in Phoenix. There's a link to book a fit call in the description. I read every comment. Well, Julia does, and she reads every one. So tell me, does a solid object in two places at once break your brain or open it? The Nature paper is linked below. Don't take my word for it, the math is in the paper. The wall between the quantum world and ours is thinner than anyone promised. The rabbit hole, my friends, just got a lot deeper. Let's go down this rabbit hole together. See you down the next one.